Hello, today I'm gonna be explaining to you CodeQL query for finding LDAP injection that was reported to Github Security Lab on Hackerone and was rewarded $3,000. First, let's explain what is Github Security Lab because it's not standard GitHub's bug bounty program. It's actually an initiative by GitHub that allows security researchers to write CodeQL queries that find actual vulnerabilities in open source software. Now you're probably wondering, what is CodeQL? So let me briefly explain it. It's the code analysis platform used by security researchers to automate variant analysis. It is not a simple static code analysis performed by a simple text parsing, nor it's a dynamic analysis. CodeQL does not actually run the application to submit payloads. It performs a semantic analysis, which means it actually understands what the code does, how does the flow look, and, most importantly from the security point of view, which variables may contain user input. So the idea behind the GitHub Security Lab is that there is public repository with all the CodeQL queries submitted by researchers that find a lot of types of vulnerabilities, and everyone can for free run those queries on their applications and find any bugs very early. And the researchers here do not get paid for the vulnerabilities they find, but for the queries they submit. And the bounty award is determined based on the following factors: the complexity, severity, and prevalence of the vulnerability, as well as the performance and documentation of the query you submit. So if you write such a query, it's a good idea to first run it on some open source applications, just to see whether it's reliable or not. And if those applications have bug bounty programs, you will get a few payouts for a job done once. Because GitHub's team will be very keen to see that your query actually finds vulnerabilities. Okay, so now we have GitHub Security Lab and CodeQL explained, and we can start getting into this very vulnerability. So now it's time to explain what is LDAP. The acronym stands for Lightweight Directory Access Protocol, and it's used for accessing and maintaining distributed directory information services. In simple words, it's used to access the same file system from a few computers connected by the internet. The very typical query that would validate the credentials provided by the user would look like this. It uses the notation where operands follow the operator. So here first we have the and sign, and then we have two expressions that both must be evaluated to true for the whole expression to be evaluated to true. And the concept behind LDAP injection is very similar to SQL injection. We have our user input unfiltered and put into the query, so we can escape the context and make the expression always return true in this case. So such payload would be equivalent to the typical SQL injection performed in the login panel. Let's now get to the actual CodeQL queries. The goal is to find any methods that execute LDAP queries on unfiltered user inputs. This single query can detect LDAP injection in plain Java GNDI, Unbound ID, Spring LDAP, and Apache LDAP API. These 4 of the 7 files that we have in this part of the repository are just examples of well-written parts of the code executing LDAP queries using these 4 technologies. One more file contains some help, so remaining 2 files are actually written in the CodeQL language. So the first file is very short. It looks a bit like a SQL query, and it's meant to be this way because CodeQL is advertised that it can work with the code as easy as with the data. So for example, such basic query would fetch all variables of type int from the analyzed code. So here, source and sink are 2 points of the flow of the application, and we want to check whether we can get from one point to another, meeting at the same time our requirements stored in a conf variable that has the type defined by us. And the select part is just what will be returned if the application will be vulnerable. So let's get into the second file. It has 400 lines and I will try to just briefly explain what's going on here, otherwise it would be a very long video. In simple words, our sink has to be a method that executes LDAP query, and source has to be something with user input. This part of the code validates that the method that we are currently in is one of 3 methods in unbound ID that are vulnerable, that is, they execute LDAP query. And here, in the Spring part of the code, we have a bit of logic because there are more functions, more parameters, not all of them can be our sinks, so we have to put some ifs here and there, but it's not a very complicated code. And big part of the code here just makes sure that we catch equivalent calls. That is, if we call our method on string, it is equivalent if we create an object of LDAP name class using the same string, as well as if we would create a new LDAP name and then use the method to string. The researcher had to write code to catch all of these variants. So that's the brief logic behind these CodeQL queries. Big kudos from me to the researcher Grzegol that actually wrote those queries and got $3,000 from Github Security Lab. I think that's a cool way of doing something great for community and having a profit from it as well. So that's it for today's video. As always, I will put relevant links like the report, the commits and the researcher's profile in the description. Leave a like and a subscription if you enjoyed the video. For now, goodbye.